Thank you. Thank you, everyone. This is Mr. OTIENO. I want to teach at a strand in grade 8 that is under integrated science, which is one of the learning areas in junior school. So our topic of the day, I want to talk about mixtures, elements, and compound. Now, this is a strand which we started this strand in grade 7, and in grade 7 we were only able to look at a mixture. Now, so the integrated science being one of the learning areas in junior school, by definition, it is the study of the three basic natural science. And the basic natural science here, I mean chemistry, biology, and physics. So there is a way the strands are arranged in a manner that include all the three basic sciences which we are talking about here. So when you look at the grade 8 integrated science strands, then you realize the first strand is dealing with chemistry. That is the strand which deals with the mixture, elements, and compound. Then now the second strand, which is supposed to be covered in second term, is about the living things and their environment, which is now biology. Then the last one is force and energy, which is now about the physics. That's why when in the definition we talk about integrated science as the study of three basic natural science. So back to the strand of today, we want to talk about mixture, element, and compounds. But I want to go back to what we learned in grade 7, where we looked at a mixture. So we need to, first of all, to understand the meaning of mixture. So a mixture simply means it is the combination of two or more substances combined together. They make what we call a mixture. Now, so if, for example, in grade 7, we talk about having a mixture, for example, we have maize. Then we mix this maize maybe with beans. Then whichever now we have is a mixture. So it is a now combination of the two. This, the maize and the beans here are the substance. So we mix them together so that we form what we call a mixture. So when we combine the two, the result here is what we call a mixture. Now then in grade 7, again, we talked about the types of mixture, whereby a mixture can be solid to solid mixture. Then we can also have liquid to liquid mixture. Then we can have solid to liquid mixture. Then we can also have air, which is also a mixture. So I want to talk about the solid to solid mixture. This is whereby we mix the two solids together as one of the so we take a solid and a solid. For example, the example I've given here, where we have maize and beans mixed together, we get a mixture. So that mixture is solid to solid because the two substances are solid as a state of matter. Then now we have liquid to liquid. This now where we mix two liquids together, and then those liquids give us what we call a mixture. So it is a liquid and liquid mixed together, give us another mixture. Then now we have solid to liquid. This is now we have, for example, we can have a solid, we mix this solid with a liquid. Then the mixture we have there is what we call solid to liquid mixture. Now I want us to look at this part here, the liquid to liquid mixture, because from there we are going to come up with another group of mixtures. So let's look at liquid to liquid mixture. So from this is where now we are going to come up with another category whereby we are going to have what we call heterogeneous mixture, and then we are going to have also homogeneous mixture. So we need to understand what is this heterogeneous mixture. Now, what is this classification here has been brought about by the families which forms the mixture, but it's only specific to the liquid to liquid. So under this, we do have the families of liquid, families of liquid, families of liquid. So we have the two families of liquid. One, we have the first one is water family. Then the second one is what we call oil family. So when these two are mixed together, then now we can come up with what we call heterogeneous or what we call homogeneous. So I will start with how to form heterogeneous mixture. So heterogeneous mixture is that kind of mixture which is formed taking one family plus another family. For example, if we take, for instance, for example, let's talk about the water family. So under the water family, here is where we have the water itself. We have milk. We can also have blood. Now these three here are from the water family. Then now we have the oil family. So under the oil family, mostly here we have petrol or the oil product. We have petrol, we have diesel, we can also have paraffin. So if we want to form heterogeneous, then we'll take one family. For example, we take water. From the water family, we can pick, for example, water. Then we mix this water with oil family, for example, petrol. The result of what we are going to form here is now what we call heterogeneous. Why do we say it is heterogeneous? It is because heterogeneous is the type of mixture which is formed by two different families, and they can be separated by a physical means. Why? Because oil and water and petrol cannot do that. They cannot mix completely. Then that's now what we call heterogeneous, and it can be separated by using a physical means. But now when we take, for example, diesel and paraffin, then we mix them together, then we are going to form what we call homogeneous. So the homogeneous, it mixes completely, and it is not very easy for us to separate them using the physical means. So the classification under the heterogeneous and homogeneous is only based on liquids, but it depends with the family of liquids mixed. For example, you mix water family together with the oil family, you form what we call heterogeneous, which can be separated. But if you mix water family and the water family, or a member of water family and the water family, then you form what we call homogeneous, which cannot be separated. And therefore, when you want to do the separation, or you put them maybe in a beaker, and then now you are able to see to look at the mixture form, you realize that the two water family and oil family will form a layer, and therefore you can separate them. But if you mix the oil family and oil family, then the mixture becomes uniform, and therefore you cannot be able to separate. That is what we learned in grade 7 about the mixture. Now the same grade 7, we also talked about methods of separation of mixture. Methods of separation of mixtures. So here we have several methods in which we can use to separate mixtures. For example, we have decantation. We have decantation as a method. So these now methods of separating mixtures. methods of separating mixtures. So we have the first method is decantation. The second method is filtration. Thank you. Filtration. We have evaporation. We have winnowing. Then the last one, we have picking. But now, what do we need to know? What we need to know here is that which mixtures can be separated using decantation, and which mixture can be separated using filtration, evaporation, winnowing, and picking. When you start by decantation, this one only is applicable where we are separating a solid from a liquid. For instance, when we have a mixture of soil and water, then we can do decantation because we realize one substance will settle. For example, if we have a mixture here of sand and soil, then we realize that the sand will settle down, or the soil will settle down here. Then we have the water at the top. So this method here, decantation can be used to separate solids and liquids. Then we have filtration. So under the filtration still, we use this method to separate again solids and liquids, whereby we can use a filter paper, or we can as well use a piece of cloth where we tie a piece of cloth here. Then the liquid part is poured on. Then now the solid will remain on top here, and that's what we call residue. Then now we get the liquids down here. That is under filtration. Then evaporation here is this. We use this method to separate the soluble solids mixed in liquids. For instance, we can use this method when we want to separate whereby water is mixed with a solid or a solid, like for example, when we have, for instance, we have sugar mixed with, or sugar plus water. So in this case, we have to go through the process of evaporation, but again, before that, we must go through other process before we reach the evaporation process. One thing we must do first of all, we must dissolve. We are dissolving so that we form a solution of sugar, or the solution of sugar. Then after dissolving so that now we have a solution, then from there now we can evaporate. So when we are evaporating, then we are going to do away with water, and then the sugar crystals will remain there. And that's how we deal with what we call evaporation. Then now we have winnowing. So in the winnowing here, it is a method we use to separate two solids. We use it to separate the mixture of two solids. But these solids, we must consider what we call the mass of these solids, whereby one is lighter, another one is heavier. So this method we can use when we are separating, for example, we are separating, when we are doing the separation, for example, the husk from millet, whereby we find that the millet is heavier, but the husk is lighter. Therefore, the lighter part will now be taken by air, and then now we remain with the heavier one now, which is the millet. So in winnowing, we must consider the weight of the two substances we are separating, whereby one will be lighter, another one will be heavier. So we'll be able to separate. Then, of course, we are picking. So in picking, it is used for separating solids. But these solids, they should be the solids which are more visible. So we can see and pick. For example, when we have maize plus beans. So when you have such a mixture, you can just put your hand, then you pick maize within the mixture, then you remain with beans. So there we use picking. Then the last one is sieving. So the sieving as a method of separation here, this is where now we separate a solid plus a liquid. But here we are going to use what we call a sieve, whereby the particles are different. So we can use it to separate solid liquid, or so we can sieve, separate through solid, the mix of solid and solid. But in this case here, we consider the size of the solids, whereby the solid with the bigger particles or sizes will remain on the top of the sieve, but now the one with the smaller particles will move down. So we can use sieving to separate liquid, solid to liquid mixture, and can also be used to separate solid to solid mixture. So that's what we did in grade 7 about the mixture. So let's now go to grade 8. Now that we are able to understand the concept of mixture, we have seen the types of mixture, the methods of separation, and we have also looked at how different mixtures are formed. Then now we can look at the element. But again, before we go to the element, we must look at the application of mixtures, or application of the separation of mixtures. So in a day-to-day life, the separation of mixture as methods are used in different areas. For example, we can use this method when we want to separate different mixtures together, and also we can use it in daily life. For example, when you have two substances mixed together, you can now have a way of which you can be able to separate. So those are some of the applications of mixture, or methods of separating different types of mixtures. Now let's now look at element. So this one, we looked at the elements, or we learned about elements in grade 8. And therefore, we must first of all start by understanding what element is. Now, so an element is a pure substance. So when you are defining the term element, you must talk of a pure substance. So it is a pure substance made up of one kind of an atom, or it is made up of one kind of a substance. That is what we call an element. So what we need to know about the element is that we cannot break element into a simpler into a simpler form, and therefore by any means, be it chemical means or physical means, we cannot break down the element. So what we must know is that element is made up of one kind of atom. We'll talk about this later so that we understand what an atom is, and then it cannot be broken down into a simpler form. And it is also a pure substance. Pure substance means it's only made up of one kind of one kind of an atom. So examples of element. Now this one we go back to in the periodic table, although we are not going to look at it into details, but the elements, we derive them from there. whereby elements, we can start with the first 20 elements on the periodic table. So when you ask to give example of the elements, we can just take, for example, we have hydrogen, which is number 1 in the periodic table. We have helium. Then, or we just take 3, then number 3 we have lithium. So these are just few examples of elements. But in grade 8, we looked at the first 20 elements. That is from hydrogen to calcium. So once we have looked at that, of these elements, now once we have known what are the elements, then now we go and look at how to write their symbols, because in science, there is a way we are supposed to write. For example, when we talk about hydrogen, then it has what we call a chemical symbol. So how do we write that? So we can look at how to write a chemical symbol for elements. So there are rules which must be followed when writing a chemical symbol of any element. So what are these rules we are supposed to follow? One, the first rule is that the chemical symbol of an element is usually the first letter. It's usually the first letter of the English name or the first letter of the Latin name of that specific element. For example, we have elements which normally derive their chemical symbol from their Latin name, and we have the ones which derive their chemical symbol from their English name. For example, if I want to take, for example, one which takes the English name and the other one which takes, for example, the Latin name. So I will take, for example, the first one, which is called magnesium. This is an element. So how do we write the chemical symbol for magnesium? So one, the rule is that when writing the chemical symbol, we consider the first letter of that element. For example, magnesium takes the first letter, which is M, and therefore M must be what we call the uppercase. Then now the second one, it will take any of these letters, any of the letters. It can take the second, the third, but it must be in what we call the lower case. For example, so like in this case, it will take the third one, which is G, and therefore it must be a small, what we call the lower case. So if in any case you write the chemical formula, for example, you write M, then you write this, then this is very wrong, because the rules requires that only the first one is supposed to be the uppercase letter, but the second one is supposed to be the lowercase letter. So therefore, for magnesium, we have this. Now, this one here, it is M because magnesium does not use, it derives its chemical formula from the English name. But now when we talk about, for example, the one like sodium, we realize that now sodium, the chemical formula is now different because sodium derives its chemical formula from its Latin name. And therefore, the Latin name for sodium is what we call natrium. So, therefore, for the sodium, we take the first letter of its Latin name, which is N here. And therefore, when we want to write now sodium, we now write N, the uppercase. We write N the uppercase, then we have the lowercase, which is A. So when you look at this, we must now be able to know which elements derive their chemical formula from their Latin name and which one derive their chemical formula from the English name. So for the ones which take the Latin name, these are like, for example, we have silver, we have copper, we have sodium, and also we have lead. So with them, they derive it from their Latin name, and therefore, when you're writing their chemical formula, you must consider the first letter of their Latin name to come up with the chemical formula. So I've said the first letter is usually must be the first letter of the Latin name or the English name. Then the chemical symbols are derived again from either it is a Latin or the English name. Then, of course, the first letter of the chemical symbol must be an uppercase, the way I've explained here. So we have M, this is a uppercase, then we have G here, which is the lowercase. So if you write this, it is correct. But if you write, for example, this, then this is very wrong. And again, if you write, for example, M, then the second is also the uppercase. This is also wrong. So the second letter is not necessarily to be the second letter of the name, but it can be either the second, it can be the third, depending on how it forms the chemical or symbol of that element. So that's how these elements are formed. But now I want us to go back to, because we have talked about element being formed by, or a pure substance which is formed by one kind of an atom. So we must also now go back and look at what is this atom we are talking about, which forms the element. So an atom, by definition, is that it is the basic building block of an element, and therefore an atom is what makes up the element. And therefore, again, this atom, we look at it later. We are also going to see what makes up an atom, because as atom makes up element, then again, atom is also made up of other things, what we call subatomic. The subatomic. So the subatomic are now the building block of an atom, and an atom has the 3 subatomics. So we are going to look at them when we'll be looking at the structure of an atom. And then we see these 3 subatomic, where can they be found? And why are they important? Because we are going to use them when we'll be studying this, the structure of an atom into details. We are going to use the 3 subatomics. Good. So once we have looked at that elements, then we need to know these elements have what we call atomic number. So the atomic number simply means the arrangement of the elements on a periodic table, whereby when you say that hydrogen is the first one in the periodic table, then the number 20 is calcium, then that the way we follow number 1 up to 20, that one now gives us what we call atomic number. For example, hydrogen is atomic number 1. Then now calcium down here is number 20. Those are what we call the atomic number. So atomic number is also very important because it is going to help us when we are now studying the structure of an element. For example, when we look at the electronic configuration of an element. So we will need the atomic number, but we'll look at it later. Then now, we can go ahead and now look at what we call compound. Compound. So what is now compound? And remember, by elements, we have said elements are pure substances. Pure substances which are made up of one kind of atom. So what about now compound? Can we say compound are also are they pure? So for the compound, we can say compounds are substances which are made up, but they are made up of two or more elements chemically combined together. So for us to come up with a compound, we must now combine two elements together for us to come up to what we call compound. And therefore, in the compound, now we don't talk about chemical symbol, but for the compound, we talk about chemical formula. Talk about chemical formula. And this chemical formula is made up of the component in that compound. For example, if it is a compound made up of two elements, then when we are deriving the chemical formula for that chemical, then we consider the individual elements that form up the compound. So it can contain, it contains more than one atom. For example, when we look at the examples of this compound, we just take one example, then we look at this example, and then we want to look at which elements make up that compound. Then from there, we'll be able to now learn on how to write its chemical formula. When we take, for example, we have sodium chloride. We have water. Then we can also have carbon 4 oxide. So these three are just few examples of compounds. Now, so when you talk about a compound being made up of more than one type of an element, for instance, when you talk about sodium chloride, we can see the elements which have been used to make sodium chloride. So we have sodium plus chloride. So this sodium is an element. Chlorine here is also an element. That one means what? There are two atoms of different kinds which makes up a compound called sodium chloride. So when you talk about sodium, it has its chemical symbol, which is this. Then we have chlorine, which is that. Now, when now we want to form now the chemical formula for sodium chloride, then we are going to consider the elements which makes up a compound called sodium chloride. Which are those elements? Sodium and chlorine. So how do we now write the chemical formula? So the chemical formula will be derived from the individual element which makes up that compound. For example, we have now sodium, then we come with what? With the chlorine. But the rules still remain. We cannot now start writing the chemical symbol for chlorine with a lowercase letter. So the rules still remain. So now we have sodium chloride. Now this one here is what we call now the chemical formula. That's the chemical formula. But when we have, for example, sodium, then this is now chemical symbol. So when you look at this, then you realize there is one atom. When you look at sodium chloride, we realize we have one atom of sodium. Then we also have one atom of chlorine. So these two mixed together, we get a compound called sodium chloride. So that's how a compound is formed. So a compound is formed by two elements chemically combine together to form what we call a compound. So we have seen on how we are supposed to write the chemical formula for compounds. Another compound, we have looked at sodium chloride. Another one is water. So are we in a position of coming up with or be able to identify the elements which makes up a compound water, because water is a compound. So when we want to now write the chemical formula for water, we must be able to look at the individual elements which makes up the compound water. Thank you. So which are these elements? So in this water as a compound, we have hydrogen, then we have oxygen. Combined together, we form a compound called water. So when we want to derive now the chemical formula for water, we must consider the number of atoms of hydrogen and also the number of atoms of oxygen which chemically combine together to form the compound water. So under this, we realize that we have water compound. The constituents elements are hydrogen. Then we have oxygen. So hydrogen has the chemical symbol for hydrogen is H. Then for oxygen is O. But again, the atoms of hydrogen is always 2, and therefore, when we want to write now the chemical formula for water, we are going to have H, which is for hydrogen. Then there is 2 atoms of that hydrogen mixed chemically combined with 1 atom of oxygen, so that we form what we call water. So now this is now the chemical formula for water, which is a compound. Next, because I wanted to look at the 3 compounds, the next one is carbon 4 oxide. So are we in a position of identifying the elements which makes up carbon 4 oxide? Those elements which makes up carbon 4 oxide, here is where we have, so we have carbon 4 oxide, which is compound. The elements which makes up that compound, one, we have carbon, then we have oxygen. So when we are writing the chemical formula, again, we consider the elements which makes up that compound. So we are now going to have this. We know we have carbon. The chemical symbol is C. Then we have oxygen, O. So how do we now form the chemical formula for carbon dioxide? Or carbon 4 oxide, sorry. So we are going to have C, which represent the element carbon, which is a component of the compound carbon 4 oxide. So once we have identified which elements forms that that given compound, then we are now able to write the chemical formula. Then we have oxygen, and you can see oxygen is a different element, and therefore it must also start with the uppercase letter. But there are 2 atoms. So this one here is a compound. So a learner should be in a position of identifying the elements which makes up that compound, and also be able to write the chemical symbol of that element. Then from there, can now be able to come up with a chemical formula for the compound formed by the two or more elements. Good. So we have looked at elements. We have looked at mixture, element, and compound. Now, we want to now look at into details what we call an atom. Because we have said that atoms are the building blocks of an element. And how do we now form the compound? Compound are formed by combining two, more than one elements combined, chemical combined together to form what we call a compound. Now let's now look at the structure of an atom, which is also one of the substance in grade 8. The structure of an atom. So by definition, we already know the meaning of an atom. We have said that an atom is the basic building block of an element. And therefore, we need to, once we have known what an atom is, now we can look at this atom into details. So we realize that atoms, they are made of what we call subatomic. So the subatomics now are the building blocks of an atom. And then an atom is the building block of elements. So what are these subatomics? So an atom, I will try to draw a structure here of an atom. It has two regions. So the two regions, the inner region is what we call nucleus. So in the nucleus, the subatomic found in the nucleus are protons, and then we have neutrons. So the protons and neutrons are found in the nucleus of an atom, the inner part or the inner region of an atom. Then we have the surrounding region, which surrounds the nucleus. The subatomic found there is called electron. It's what we call electron. So once we have known the structure of an atom, we know it has a nucleus. And what do we have in the nucleus? We have protons and neutrons. Now, this proton and neutron, they have different charges, whereby we have proton has the positive charge, neutron is neutral, and then electron has the negative charge. So just to go very fast and look at this. If we have, let's take for example, we have this element called sodium. Because of time, I'll just look at sodium very fast. So we must be able to know, with the sodium, we must know what we call the number of protons, neutrons, electrons, and then now we come up to what we call the mass number. So what is now the mass number? The mass number is the sum of the subatomics in the nucleus of an atom. For example, when we want to get the mass number of sodium, then we are going to add the number of protons plus neutrons found in the nucleus of the sodium as an element. So sodium has the number of protons are 11, then neutrons are 12. So when now we want to present, for example, the sodium, we'll write it this way. The chemical formula, the chemical symbol, for example, chemical symbol. Then now we cap the mass number is now is now that's up here. So we add the number of protons plus the number of neutrons. So we have 11 plus 12, we get 23. So that 23 is written here. And therefore, this one here is now the mass number. How did we arrive at the mass number? We have added the number of protons plus the number of neutrons. Then down here, now is where we write what we call the atomic number, which is the same with the number of protons. So here is 11. Now, when now we want to write, write the electronic configuration of this element sodium, then we are not going to consider the mass number, but we are going to consider the number of the atomic number, which is number 11. So let's now very fast write the electronic arrangement of sodium as we wind up. So we'll start by the nucleus. We have protons, we have said there are 11. Neutrons, we have said there are 12. So there are rules for writing the electronic arrangement. We must know what we call the energy level. So the energy level refers to the regions of an element which are occupied by electrons, which is one of also the subatomic of an atom. So we go and draw the first energy level. But what we need to know, student, we need to know that the energy level, we have this rule 288. That one means what? The first energy level must accommodate a maximum of 2 electrons. And it is the electrons which we are using here, not the protons or neutrons. Then we have the second energy level also has 8. The third energy level also have 8. That is now what we are supposed to know in grade 8. So from there, the number we are dealing with is number 11, which is here, the number of electrons. So from there, we know that the first energy level must carry a maximum of 2. Therefore, we have this, the first energy level, we have 1, 2. This 2 must be subtracted from 11, then the total number of electrons. So when we subtract 11 minus 2, we remain with 9. So we still have 9 more electrons to arrange. That one means what? We are through with the first energy level, and therefore we are going to the second energy level. The second energy level must carry a maximum of 8. But we have already 9 electrons remaining. So it is now 9 minus 8. So we have 1, 2, 3, 4, 5, 6, 7, 8. So what is remaining is 1. So the second energy level is full with 8 electrons. Therefore, we are going to the third energy level because we still have 1 more electron remaining. So we go to the third energy level. There, we only have 1. And therefore, the electronic configuration of sodium now will be 2, because there are 2 here. Look at the first energy level. It has 1, 2. So the 2 electrons. Then you go to the second energy level. We have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 there. Then we go to the second energy level where we have only 1. Now, once we have done this, then now we can be able to classify these elements into metals or non-metals, because we'll see, there's a rule that we look at the number of electrons on the outermost energy level, and that one now we can use that to tell whether this substance is an is a metal or non-metal. For example, if it has 1, 2, and 3, then those are metals. Those are metals. If they have 4, 5, 6, those are now non-metals. So we can look at this. Sodium has 2, 8, 1, and therefore it has 1 here. Now we can tell sodium is a metal. So from there, a learner can be able now be in a position now to even to classify this element into metals or non-metals, after the learner is now able to understand how to write electronic arrangement of a given metal, or sorry, of a given element, then now they look at the number of electrons in on the outermost energy level. Then from there, they can be able now to classify an element as a metal or non-metal. Up to there, I just want now to thank you for watching, and I would like again now to advise the learners to continue revising very well, because these are very they are new things to them, but with the determination and a proper programming, and also revising the teachers the work which have been done, then they'll be able to get the concept. Thank you very much for watching.